Hello and welcome to the last four sections of Chapter 1. Today we're going to take a look at signed numbers, some properties of real numbers, and simplifying algebraic expressions. So to begin, signed numbers are just our integers, things like -2 and -1, 3 and 4 are signed numbers. These are our integers. So if we want to, say, add signed numbers, we can take, say, -2 plus -1. And when we have it set up like this, we want to make sure we have parentheses around our signed number so that we don't have two symbols right next to each other without parentheses there. Anytime we go to add numbers of the same sign, here two negative numbers being added or two positive numbers being added, we can simply add the absolute values of these numbers. So for example, 2 plus 1 is 3, and then we keep the sign that was in front of both of those numbers, negative. So -2 plus a -1 is a -3. Similarly, 3 plus 4 is 7, just as we've always done it. If we are adding signed numbers of different signs, say for example 3 and a -2, if we're adding them together, make sure you keep those parentheses around the negative number. So 3 plus a -2, we can always think of this the same as we did 3 minus 2. Anytime you're adding a negative, it's the same as subtracting that positive number. So here, 3 plus a -2 is going to be 1, just like 3 minus 2 is 1. Another way to think about that, say I have -11 plus 9. If we see they have opposite signs, one negative, one positive, we can subtract the absolute value of the smaller from the absolute value of the larger. So for example, 11 minus 9, which gives us 2. And then for this problem, -11 plus 9, that 2 will have the sign of the larger absolute value, so -2 in this case. We can apply this to that previous problem as well, 3 plus the -2. Okay, again, take the absolute value of the smaller number, subtract it from the absolute value of the larger number, 3 minus 2, which gives us 1. So in this case, that 1 has the sign of the larger absolute value. The 3 here is positive, so our answer is 1. So that's two different ways to look at adding numbers with a different sign. You can use these same techniques when subtracting signed numbers. Say 7 minus 4. We have a positive 7 minus a positive 4. This is the same as we've always done it, 3. But let's say instead we have -11 minus 2. Well, in this case, we can think of it as -11 plus a -2. Again, the same thing here as adding two numbers of the same sign. Okay, again, we add 11 plus 2 to get 13, and then keep the sign of the two numbers, negative. So -11 minus 2 is a -13. What if we have 11 minus a -2? So we saw in our last video, anytime we have a negative next to a negative, that's the same as a positive. So this is actually 11 plus 2, or just 13. We can also think of these problems as going along a number line. So if I had, say, 9 minus 7 plus a -2, let's go and work this out using a number line. So on my number line, if I start here at 9, minus 7 is going back along this number line 7 times. So we'll go down 7 to 2. Then if I'm adding a -2, adding a -2, again, that's the same as subtracting 2. So again, it's going left on this number line. Again, another 2 places down to 0. So we see 9 minus 7, which got us down to 2, plus a -2 brings us down to our answer, 0. Make sure you practice a lot with signed numbers so you get used to which direction you're moving and whether your answers are positive or negative. Multiplying and dividing signed numbers can actually be a little easier. Say for example we have -2 times a -3, or even 2 times 4. We can multiply these together. Anytime you're multiplying numbers with the same sign, your answer will always be positive. So 2 times 4, as always, is 8, and -2 times a -3 is going to give us a positive 6. So again, anytime you have numbers with the same sign, a negative times a negative or positive times a positive, your answer will always be positive. On the other hand, if you're multiplying things with a different sign, say -2 times a positive 3, or -7 times a positive 9, anytime they have a different sign, positive times a negative, your answer will always be negative. So in this case, -6, or -7 times 9, a -63. We have to be careful with this when we're applying it to exponents. So for example, when I have -2 squared, this is saying I'm taking that -2 and squaring it. So -2 times -2, that's a negative times a negative, so it is positive 4. Whereas if I write it as -2 squared without the parentheses, this is now just the 2 being squared, and the negative sign is just out here for the ride. So I have that negative sign, which will stay there no matter what, and 2 squared, which is 4. So there's a big difference whether you have parentheses or not when it comes to exponents. The same properties for multiplication are involved with division. Say I have -12 divided by a -4. Okay, a negative divided by a negative will always be positive when you have that same sign. So -12 divided by -4 is a positive 3. -9 divided by 3, in this case, a negative divided by a positive is going to be negative. When they have that opposite sign, your answer is negative. So in this case, -3. So before I give you the answer, take a look at this problem. What should my answer be? That's right, -3. And the sign is negative because they're opposite signs. Next we'll take a look at the properties of real numbers, starting with the commutative property. The commutative property basically says if I add 3 plus 4, that's the same as adding 4 plus 3. The commutative property says that I can add things in any order and it does not matter. The same applies for multiplication. If I have 2 times 6, that's the same as multiplying 6 times 2. They both give me 12. The commutative property, however, does not work for subtraction. If I have 7 minus 3, it is not the same as 3 minus 7. 7 minus 3 is 4, where 3 minus 7 is going to be a -4. Same holds for division. If I have 8 divided by 2, it is not the same as 2 divided by 8. 8 divided by 2 is 4, where 2 divided by 8 is 1/4. So the commutative property holds for addition and multiplication, but not for subtraction and division. Next, the associative property says that if I have 3 plus 4 plus 2, where I group the 4 and the 2, that's the same as 3 plus 4 plus 2, where I group the 3 and the 4. Again, it does not matter which I group first, which I add together first. 4 plus 2 is 6, plus 3 is 9, where 3 plus 4 is 7, plus 2 is 9. They both give me the same thing. It also works for multiplication. If I have 2 times 3 times 5, where I multiply the 3 and the 5 first, it's the same as 2 times 3 times 5, where I multiply the 2 and the 3 first. Again, 3 times 5 is 15, times 2 is 30, 2 times 3 is 6, times 5 is 30. Again, they both give me the same answer, and does not matter which I group first. Again, this does not work for subtraction. Say I have 10 minus 3 minus 1. It's not the same as 10 minus 3 in parentheses minus 1. In this case, I do the 3 minus 1 first, which gives me 2. 10 minus 2 is 8. And on this side, I do the 10 minus 3 first, 7. 7 minus 1 is 6. So they don't give me the same answer. Also, with division, if I have 18 divided by 9 divided by 3, this is not the same when I group these as when I take 18 divided by 9 together first and then divide by 3. Here 9 divided by 3 is 3, 18 divided by 3 is 6. Here 18 divided by 9 is 2, divided by 3 gives me 2/3. So again, this does not work for subtraction and division, only for addition and multiplication. So a quick recap, if I have 5 times 8y is the same thing as 8 times 5y, this property is the commutative property of multiplication, because I have changed the order of the numbers. Where if I have 5 times 8y equal to 5 times 8 in parentheses times y, this is the associative property, because here I am grouping 8y together, 8 and y being multiplied first, and then by the 5. Where here the 5 times 8 is being multiplied first and then by the y. The distributive property says that if I take 2 times 3 plus 2, then that is the same as 2 times 3 plus 2 times 2. Redistributing here, instead of adding first and then multiplying by 2, I can distribute this 2 to each piece inside the parentheses. 2 times the 3, and then add it to the 2 times 2. So in this first case, 3 plus 2 is 5, times 2 gives me 10. Here, 2 times 3 is 6, plus 2 times 2, 4. 6 plus 4 is 10. They both give me the same answer. Let's see that with some negative signs thrown here. Say negative 2 times 5 minus 3. That should be the same as negative 2 times 5 plus negative 2 times negative 3. Here 5 minus 3 is 2. Negative 2 times 2 is a negative 4. Negative 2 times 5 is a negative 10. Plus negative 2 times negative 3, they have the same sign, so a positive 6. Negative 10 plus 6 is a negative 4. They both give me the same answer. Next, the identity property. Anytime you add something by 0, right? 0 plus 2 or 2 plus 0, either way you get your 2 back. In a general form, this would look like 0 plus some variable equals the same thing as that variable plus 0, or just x. It can come in segments too. It could just be x plus 0 equals x, or 0 plus x equals x. So two different ways that you might see the identity property listed. The same thing works for multiplication with the number 1. 1 times some number, or that number times 1, always gives you back the number you started with. 1 times x equals x times 1, which equals x. Multiplying by 1 just gives you back what you were working with. The inverse property, on the other hand, is saying when you have some letter and you add to it its opposite, a plus negative a, it always gives you 0. Or for example, 2 plus a negative 2 is going to give me 0. Anytime you add something to its opposite, it's 0. For multiplication, the inverse property is anytime I take, say, 5 and multiply by its reciprocal, 1/5, it always gives me 1. Any number you choose times its reciprocal will always give you 1. So if I have 2/3 here and I want to multiply it by something to get me 1, I can multiply by its reciprocal 3/2, and that is going to give me 1. So anytime I multiply something by its reciprocal, that inverse property tells me it's 1. Plus we see our 3's cancel out, our 2's cancel out, and indeed we just are left with a factor of 1. Now let's talk a little more about variables. To start, we'll take a look at a term. A term has a number part, a coefficient, and a variable part, the variable. Okay, and it can also have an exponent. So this term has its three parts, the coefficient, the variable, and the power. It can have all of those or just one of those. 2 on its own is a term. For x, y is a term. You can have more than one variable. Or say 3y, right? No exponent, you can just have 3y as a term. As a side note, if I don't see a power here, I can always assume that it has a power of 1. Anything to the first power is itself. So that's why I don't include the 1, but it is still there. We want to understand our terms because we can add like terms. Like terms do not have to have the same coefficient, but they do have to have the same variable to the same power. In this case, both of these terms have the variable x, and they're both to the first power, which means I can add these two. In order to do that, you always add the coefficients and keep what made it the like term, that x, keep it the same. So here we have 5x. Another way to think about this, 3 times x, remember multiplication is just repeated addition. 3 times x is just x plus itself 3 times, whereas 2 times x is the same as x plus itself twice. So really I have here 5 x's that I'm adding together to get my 5x. Some more like terms. Numbers on their own, 2 and 4, those are like terms. They don't have variables, so they're alike. 3x and 2x we saw are like terms. 2yx and 7xy. Be careful with this one. They're in different orders, but they are like terms. They both have the same variables, x and y, and those variables are to the same powers. X and x are still to the first, y and y are to the first power. So these are like terms. Also, x squared y and 7x squared y are like terms. They have the same variables to the same powers. On the other hand, x, y squared and x squared y, these are not like terms. The x's are to different powers, one to the first, one to the second, and the y's are to different powers as well. So again, these are not like terms. 3x and 5x squared, these are also not like terms. Again, the variables are to different powers. 2y and 7x, these are not like terms. They have different variables. So all of these, right, we cannot add them together because they are not like terms. Let's go ahead and add some more like terms. Say I have 3x plus 2x plus x. Another way to think about this is with the distributive property. We saw before, right, if we had something outside, right, with each piece inside here, that was the same as that one piece being multiplied by each one separately. So we can take this and go backwards, take that x that is in each one, pull it out, and then we are multiplying it by that quantity of 3 plus 2 plus 1. If there's no number in front, we can assume a coefficient of 1. So here we have 3 plus 2 plus 1, 6 times x, that's 6x. Also, if we look at it up here, again, remember it's adding the coefficients. 3 plus 2 plus 1 gives us our 6x. Let's do something a little more complicated. Say 2y minus y plus 3. Here we need to distribute this negative sign. Negative times y, so we have our 2y out front, minus y, minus 3. Again, distributing that negative to each piece. Now we simplify by combining our like terms. Here's a like term, and here's a like term. They both have y's to the first power. 2y minus y, remember that's minus a 1y. So 2 minus 1 is 1. So we have 1y, or just y. and then our negative 3 has no terms like it, so we just bring it down minus 3. So we have simplified this algebraic expression to y minus 3. This cannot be simplified any further because y and 3 are not like terms, so they cannot be combined. Let's do another one. Say we have 3y squared minus z plus 4y squared minus 2z. We need to identify the like terms first. These are our like terms, 3y squared and 4y squared. They have the same variable to the same power. Also, our z terms have the same variable to the same power. So we can combine those as well. Here, 3y squared plus that 4y squared gives us a 7y squared. Here, a negative z combined with our negative 2z will give us a negative 3z. Anytime you're doing this all in one step, like we just did, the sign in front of the variable, so the sign just to the left of that term, needs to stay with that term. I treat this all as one piece, this all as one piece, and this all as one piece. Okay, that negative to the left of the z stays with it. Our last example here, 12x minus 8 all over 4. This is an interesting problem because it is written as a fraction. We can write this out as two fractions, 12x divided by 4 minus 8 divided by 4. What we see here is if these were our original fractions, they have a common denominator, which means I add their numerators. 12x minus 8 is my new numerator, 12x minus 8, and I keep the same denominator of 4. I can split up this fraction into two fractions by separating it by each individual term that was in the original numerator. So here I can simplify these two pieces. 12x divided by 4. I can divide any two terms I like. It does not have to be like terms. 12x and 4 are not like terms, but that does not matter. Here when I'm dividing, I can just focus on the numbers here. 12 divided by 4, which gives me 3, which is still being multiplied by that x. Now I'm going to subtract 8 divided by 4, which is 2. And I have 3x minus 2. I cannot simplify this any further because they are not like terms. So this is my final answer. Congratulations, we've just finished chapter 1. Feel free to go back in this video to clarify anything you didn't understand, or go to the discussion board found in Blackboard to ask whatever questions you have, or to see if someone else has already posted that question. Also, don't forget to do the homework and quiz for chapter 1, and I will see you next week for chapter 2.